Okay, so last one. Now we're going to look at n plus 2 squared minus 1. Okay, maybe we can do these in green. All right, what do you want to do for this equation?
I'll do the one value.
Okay.
So 3 squared. So we just need a 3 squared. And then
Do you have a 3 by 3 or a 3 by 1 there you made? Okay. You can put it down so it doesn't need this.
okay, so 3 squared minus 1.
All right.
Well, now we can take off this part and put it like this from that.
Okay. All right, so that's interesting. So 3 squared minus 1 actually could be rearranged pretty easily into that 2 by 4 just by flipping that part down there. That's lucky. Okay.
All right, now we're going to need 5 squared minus 1. Hopefully
5 squared minus 1, okay.
Hopefully we'll have enough.
Yeah, hopefully. 5 squared minus 1. What does that equal, by the way, while we're building this 5 squared?
It would be 24.
Okay, so there's 1 5. You don't have to connect them.
That's a 4.
Oh, and by 5, I'm in... There's that. Okay, so we need 2 more 5s. I got 2, 3, 4, plus 1. Okay, so here's our 5 squared coming together. All right, minus 1.
So, quick.
All right, and what is that?
It's 24.
And does that match that?
Yep.
So, hey, this one looks like it does have a pretty interesting geometric interpretation. You take the one off and then you just flip this part up over here, okay? So maybe that will be easy to see for the case n equals 4. What do we have?
Well, we have 6 squared minus 1.
Okay, what's going to happen with the 6 squared?
So, you take one out and then you flip the layer onto the other side.
Okay, and what's going to happen when you flip it onto the other side?
Well, you're going to get something that's only 5 high but 7 long.
And what's that?
5 by 7.
Which is?
35.
Okay, so it turns out interestingly here, understanding this as a square, understanding the squaring operation as making a geometric square actually leads to a very neat connection between this equation and the first equation. And we couldn't quite see the connection with this equation either time, but these two equations very naturally related to each other. N plus 1 times n plus 3 and n plus 2 squared minus 1. Can you see any algebraic reason why n plus 2 squared minus 1 and n plus 1 times n plus 3 relate to each other?
Well, when you multiply these out, this one here, this is n squared plus 4n plus 4 minus 1. So this is n squared plus 4n plus 3.
Okay.
And this is 2.
All right, so when you multiply them out, they're the same.
Yeah.
Okay, interesting. Can you see a way to get a direct relationship between these two equations without necessarily multiplying them out?
We could do, this is n plus 2 times n plus 2 minus 1.
Yeah?
This is n plus 2 minus 1 times n plus 2 plus 1.
Ooh, you lost me there.
Well, actually that...
What are you doing?
That wouldn't...
What idea were you using?
Well, so this is... So this one is n plus 2 times n plus 2 minus 1.
Okay.
And then this one here up there is n plus 2 minus 1 times n plus 2 plus 1.
Okay. What are you doing here?
I'm not sure if this is gonna help or not.
Oh, I see. Okay. This is n plus 2 minus 1 times n plus 2 plus 1.
Well, you have to multiply these out first, so...
Well, but I don't want you to necessarily multiply them out. You found a potential interesting relationship. This is n plus 2 minus 1. This is n plus 2 plus 1.
Well,
Does that remind you of anything?
Well, maybe a difference of squares. Though, actually, no, that it's not inside these it might.
What's this?
That's a difference of squares
Why?
because this is a square and that's a square.
What is this squared?
That's n squared. That's n squared plus 4n plus 4.
It's n plus 2 squared,
Yeah,
right? What's this squared?
it's 1.
1 squared.
Yeah,
So this is n plus 2 squared minus 1 squared, which we can write as,
it's n plus 2 minus 1 times n plus 2 plus 1.
it's interesting. So the difference of squares relates this to this.
Yeah,
Pretty neat, right?
yeah.
Didn't expect to see a difference of squares come up here, did we?
No, you didn't.
Even though I'm sitting in a chair, a difference of squared. All right, hey, it's pretty neat. It's pretty neat that this is a difference of squares and it relates them. All right?
Yeah.
All right. Good job, guys. Very good job.